Alright, so let's conclude talking about vertical and horizontal transformations by now putting all of those transformations together. Okay, so if you haven't noticed, this handout is posted with the announcement, and I will pass out any copies in class for those of you that don't have access to a printer. Now, all this list is at the top of the page, so if I'm going to combine vertical and horizontal transformations, remember there were three, for each type of transformation there are three possibilities, right? So for both vertical and horizontal transformations there are three steps. There is a scaling that takes place, possibly followed by a reflection, and then finally you would do your shifting. And all I've done here is I've basically just taken the three steps of horizontal transformations and added the three steps for vertical transformations. So these are also on the previous handout, albeit separately. Now, what I want to first draw attention to is the general form of a transformation of a given function f. So given a function f and four values a, b, c, and d, making sure that a and c are non-zero, okay, that's this piece right here. So given those four real numbers with a and c non-zero and a function f, the graph of y equals c times f of a times x minus b, and then on the outside plus d. It's obtained from the graph of f by performing the following transformations in the following order. Now again, all I've done here is I have the first three steps are just the horizontal transformations given by a and b, and then the last three steps are the vertical transformations given by c and d. Okay, so if you will, these first three steps here, these are your horizontal transformations. Notice that we're using the letters A, B, C, and D for a reason, because you should apply the transformations in the order that those letters are given. So you would do the transformations that given by the scaling factor A first, then you would do your horizontal shifting by whatever the value of B is, and then once you've dealt with A and B, you now move to the vertical transformations. And again, C is going to tell you what kind of scaling you have, possibly with a reflection, and then capital D is going to tell you what kind of vertical shifting that you have. Okay, so first example, I'm going to do this graphically, and then I'm going to do this algebraically. Okay, so example 1. It says, find the algebraic form of the function g of x, whose graph is identical to the graph of h of x equals x squared, but transformed in the following order. So we have 5 transformations. We're going to compress horizontally by a factor of a third. We're going to shift left 1 unit. Okay, so there's those 2 horizontal transformations, followed by the 3 vertical transformations, the first of which is compressing vertically by a factor of 1/3, then reflecting over the x-axis, and then finally a shift up 2 units. Okay, now the first thing that we're going to do is, okay, I'll write this down on the bottom. So the function g of x is a transformation of h. So I'm going to do c times h, and then in the parentheses it's a times x minus b plus d. Okay, so I'm just writing down the framework here. Now there's two things that are fixed, right? H, this is just the name of the given function. And x, remember that's just the independent variable. Okay, so in the first step, when I always do this, my goal is to find A, B, C, and D and replace them in this general expression, or this skeleton or this framework, if you will. Okay, so I'm going to come up here, and okay, so first of all, I've got a compression horizontally by a factor of 1/3. Okay, so that's telling me about the horizontal scaling factor A, and the thing you always have to be careful with is when you're doing horizontal scaling, okay, the value of A is always the reciprocal of the factor that you're scaling by. So if you're scaling by a factor of 1/3, A is going to be 3, and furthermore that would be -3 if there was a horizontal reflection, which in this case there is not. Then you're going to shift left 1 unit, and when you go left 1 unit, that's going to tell me that capital B is -1. Okay. When you compress vertically by a factor of 1/3, okay, so if I look at these two together, notice that there is a reflection after the vertical scaling. Okay, this time you don't take the reciprocal, so whatever factor you are scaling by vertically, okay, there's no need to take the reciprocal for capital C. But do make sure, notice that there is that's followed by a vertical reflection, so C must be a -1/3. And finally, shifting up 2 units is going to tell me that capital D is +2 because we are going up. Okay. So the next thing I'm going to do is, down below, I am going to replace the values of A, B, C, and D. Okay, so now what? C was -1/3. You don't touch H yet, that's just the name of the function. We see that A is 3, B was -1, so I have x minus -1, parenthesis, so I'll close off that parenthesis for the -1, close the parenthesis for the x minus B, and then I have to close the parenthesis I have to close off the parenthesis that began right after H. And then lastly, what you're going to do is you're going to add the value of D, which is +2. Okay. Now I'll do one little quick step in here, is I will simplify what I have in the parentheses, or at least the x minus -1, so I have -1/3 H. H of 3 times now x minus -1 becomes x plus 1. Again, notice here you're shifting left 1 unit, but an x plus 1 appears. So I always like to think that the direction that you shift is opposite the sign that appears in this expression. And then finally you have a +2 on the end. Okay, and actually I made a mistake. I do not need that parenthesis right there. So this should just be a +2. Okay. Now remember, the original function h of x was defined as x squared. Okay. So what I'm going to do now is I'm going to evaluate the function h. So notice that the input is 3 times x plus 1. That's going to replace this x up here. And ultimately what I'm doing is I am replacing this whole part. So the -1/3 stays out front, the +2 stays on the outside, on the back, and I'm replacing, or I'm evaluating h of 3 times x plus 1. Okay. So now this is going to equal -1/3. And notice h is just the square function, so you would just take the input of 3 times x plus 1, and I'd be squaring that and adding 2. Okay, in the next step now, what we're going to do is we're going to bring the square in. So notice I have a multiplication of 3 times x plus 1, so I have to square 3 and square x plus 1. So I end up with a -1/3 times 3 squared, which is 9, times an x plus 1 squared, and then I still have the +2. And finally, the last step, okay, I can multiply this -1/3 times 9, which would give me a -3. So at the end of the day, the function the function obtained by transforming h would be -3 times x plus 1 squared plus 2. Okay. And again, I could simplify this further. We're going to see that the form that I have it in right now is a special form called vertex or transformation form. It's really useful when graphing quadratics. You could square the x plus 1, distribute the negative 3, and add like terms. That'd be putting it into what is called standard form, and again we will talk about that in either the next section or the following section. Okay, so that's an idea of how to do this algebraically. Now we'll move on and do a graphical example. Okay. So now, example 2. Now I've been given a graph of a function y equals f of x. You'll notice this is the same function f from the first handout that we went over on Tuesday, and I finished in my previous video. And I want to draw a graph of the function g of x equals negative 2 f of 2 times x minus 1 plus 1. Now I have forgotten a parenthesis here technically. There should be another parenthesis right there. Okay. Now, it's just good practice to probably identify the values of a, b, and c. Okay, so if you look, and I could probably also describe the transformations as well and write them down. I'll just verbally describe them. So if you look at the inside changes, you'll notice that a is equal to 2. Maybe I will describe the transformations. Okay, so a is equal to 2, and remember that is going to be a it's greater than 1, so that corresponds to a horizontal compression by a factor of 1/2. Okay, so the first step is to compress the graph towards the y-axis by half, or a factor of 1/2. Then you'll notice that on the innermost set of parentheses you have x minus 1. So capital B is positive 1. This is telling us to do a shift right 1 unit. So you're going to add 1 to... So A is going to tell me to multiply x coordinates by a half. B is going to tell me to then follow that up by adding 1 to all x coordinates. Now work your way on the outside of the parentheses. Okay, I've got my capital C and my capital D right here. I'll just leave that in red. So capital C is negative 2. Okay. This is going to be a vertical stretch by a factor of 2. Okay, followed by a vertical reflection, or a reflection over the x-axis. Okay, and then lastly, D is going to be positive 1. We are going to shift up 1 unit. Okay, and basically, again, all this comes down to is you just have to multiply and add the right things to the x-coordinates, and multiply and add the correct things to the y-coordinates of certain points on the original graph. Okay. Now the way this works is I like to make a little table. Okay, so this is the function f right here. And I'll make a little table x and y. So I'm just going to pick off these, I'm highlighting them right now. I'm going to pick off these 4 points on the graph. I think we saw that the coordinates were negative 2, 0, 2, 4. And the y coordinates were negative 2, 2, 1, and 1. Okay. Now, what I'm going to do is I'm going to work my way left and work my way right. So when I'm working to the left, I'm going to be performing operations on the x coordinate, and I'll show you how I label this. Okay, so I'm going to add a new column to the left, And remember, if you look up to the right, A was 2. That's a horizontal compression by a factor of 1/2. So what I'm going to do is I'm going to actually multiply x coordinates by a half to get -1, 0, 1, and 2. And then remember, it was x minus 1 inside the innermost parentheses. That means b is 1, and there's a shift right 1 unit. So now your job is to take your previous x coordinates and add 1 to get 0, 1, 2, and 3. Okay, so these are my new x coordinates on the graph of G. Okay. And now I'm going to apply transformations to the y coordinates. Okay, so C was -2. Now you can do the vertical scaling and the reflection at the same time if you just take -2 times the y coordinates. So it's okay to just view those two transformations as one separate operation. So now multiply all your y coordinates by -2. And if maybe I should write this up here. This is because A was 2 and this is because B was 1. Now what I'm doing is this is because C was -2. So now I multiply all these y coordinates by -2. I get -4, 4, 2, and 2. And then D equals 1 tells me to do a shift up 1 unit. So I'm going to take previous y coordinates and add 1 to get -3, 5, 3, and 3. Now you'll notice that I actually need to go back. Some of you probably noticed that I actually made a mistake because I'm supposed to multiply y coordinates by -2 to get 4, -4, -2, and -2. Then I can add 1 to get 5, -3, -1, and -1. Okay, sorry for the mistake there. Now these are the y coordinates that are going to be on the resulting graph. Now I can plot these 4 points. Okay, so the first x coordinate is 0 and the first y coordinate is 5, so I'm going to go up to 0, 5 on the graph. The next when the x coordinate is 1 on the graph of G, the y coordinate is -3, so I'm going to go right 1, down 3. Okay, there's my point right there. And then I'm going to go, the next point would have coordinates 2, -1, so I go 2 right, down 1. And then finally the last point would have coordinates 3, -1, I go 3 right, and down 1. Okay. And notice that when I wrote my original table here, I made sure that I wrote down the coordinates of the points moving from left to right. Okay, since those original points are connected by line segments, the resulting points are also connected with line segments. Make sure you're paying attention to the order. There would be the graph of G. And you can kind of see, the horizontal compression because the graph is not as wide as it once was. You can also see the vertical stretch because the graph is taller than it once was. You can see the reflection because I guess the graph has been turned upside down, and then there has been some shifting. There's been vertical and horizontal shifting. Okay. Homework is open, both online. The written homework is posted. Make sure you get a start on the homework in class on Thursday. What we're going to be doing is it's just going to be a homework day where people are allowed to work on the homework for this section, and I will be there to answer any questions and possibly maybe give people help or do something on the board if I notice everybody's struggling with the same problem. Thanks for watching. Keep working at it, and I'll see everybody tomorrow on Thursday. Thank you.